So from today we are covering a most important topic, that is trees. So this is one of the most important data structure. It is a non-linear data structure because unlike linked list array, these are called as the linear data structure. Stacks, queues are the linear data structure. So graphs, trees are the non-linear data structure. So before going to tree, let me tell you what all we are going to cover and what all you get in this playlist in under tree playlist. Here we are going to cover all the basics of tree, from basic, like even from theory part we are going to cover, and obviously we are going to cover coding part. Then we are going to cover all even binary trees. I have separate playlist for binary, which I'm going to add to this playlist also. After that, have I will cover AVL trees and red black trees, and everything will be covered in this playlist. And let me start my discussion. So, what is tree? Tree is a non-linear data structure, right? It is a collection of nodes and edges. So this is the most basic um, definition that you can give. So it is a collection of nodes and edges, right? But even graphs is a collection of nodes and edges. So let me extend my definition further. So tree is a non-linear data structure which has nodes and edges, and it will have a single root node. So it will have a single root node, and rest of the nodes, like the rest of the nodes are subdivided, means they are divided into disjoint subsets, and each subsets forms the subtrees, right? This is my definition of tree. So let me tell you what is the root node. This is a root node. This is a root node. From this node, and why we call it as a root node, because this is the, from this node all other node will start. So it has no parent at all. For this A there is no parent. So again, what is parent? So let me discuss it one by one. First of all, again, tree, let me define it. Tree is a non-linear data structure which has nodes and edges, and it has a single root node, and rest of the nodes are subdivided into disjoint subset where each of them form the subtrees. Okay, subtrees, I will again tell you what each and every keywords that I told in this definition, but definition is so much important. Now, root node, the node which has no parent, or the node which it is the highest node in the root structure. The highest node in the root structure which has no parent, that is called as the root. It has no parent. See, nothing is coming from A. So if I take the node E, which is its parent? Its parent is B, right? For B, what is E? It is child. So I can tell E is a child of B and B is a parent of E. So like that, there will be no parent for A, and it is a highest node in the structure of tree. Then let us go to subtree. Any node in a tree and its descendant are called subtrees. Means you take any node, like I will take a node that is B, then its a descendant. Descendant means what? Which comes below it, like its child, its grandchild, everything. I am not talking about E, F, H, I, J. These are not its descendant. B's descendant are E, right? Let me first see what are the descendant. F and G. F and G are the descendant. Okay, for D, what are the descendant? H, I, J. Again, if I am going to add another, let me add H, I, J, K. I will add K. Right, I will add like two more things, K, L, M. Okay, so now if you consider B as a node, now this node and its descendant means H, I, J, L, M, all these 5 are its descendant, which comes after D. So the node and its descendant forms this subtree. So this is one of my subtree. This is a subtree. So this is also one of my subtree. So this is also one of my subtree. So this is how subtree means. Subtree means node and its descendant forms this subtree. What is parent? It is simple, right? Which has child, that is called as parent. So for D, D is a parent of what? Hij. This is a parent of Hij. It is a grandparent of Lm. We can tell like that also. Then next topic is child. What is child? Child is nothing but the node which has parent, that is called as child. Right? So B, C, D are child of A. E is the child of B. K is the child of G. These are things like we can say. Next, siblings. Siblings means what? So the nodes, for example, I will take the nodes which comes in the same level, right? Same level. Say I have written level here. Level and height I have written, right? What are they? So height will always start from 0. This is the 0th height. This is first height. This is second height. This is third height. And then level. This is the first level. These all 3 nodes is a second level. These all 6 nodes are third level. These are fourth level. So this is what level and trees means. And I will tell you the definition of that also. Before that, let us discuss what is sibling. The nodes which comes under a single level, on the same level, right? Which comes under same level, under a same parent. Like C is their parent, right? For F and G, C is the parent. So the nodes, let me go down. Okay. So F and G are the child of C, right? So they form the sibling. Here H, I, J are sibling, right? E has no sibling. I can tell that. E has no sibling because it is only single child of B. Then B, C, D are siblings. But you can't make K and L are not siblings because they are not from the same parent. So the nodes which comes under a same level, which has same parent are called siblings. Now descendant. As I already said, descendant. The set of nodes that can be reached from the particular node means these sets of nodes that I can reach from this particular node. Let me take that particular node as D. So what are its descendant? As I said, H, I, J, L, M. So the nodes, these are the nodes that can be reached from this node, right? H can be reached from D. I can be reached from D. So from C you can't reach H. You can't reach I. You can't reach J. You can reach these nodes only from D. So you can reach L from D. You go to D, you go to I, then L. You can reach M from D. D, I, M. So the set of nodes are these in my example. This set of nodes that can be reached from particular node, right? The set of nodes that can be reached from particular node are called as the descendant. It's a set of nodes. Again, here these are the set of nodes that can be reached from particular node. Here that particular node is C. So this is what descendant means. What is ancestor? Means for any node, all the nodes along the path from that node to root node. Means I will take this as a node. So for any node you can take, let me take J as my node. So all the nodes that you can reach along the path from this node to that tree, that is a root node, are called the ancestors. So for K is the node. If it is a node, all the nodes that you can reach along the path, all the set of nodes that you can reach along the path to the root node. So for K, G, C, A are ancestors, right? For J, D, A are ancestors. So that is how I can define ancestor as. And then degree of node. Degree of node means number of child. What is the number of child of A? So it has 3 child. So its degree is what? 3. Okay. What is the how many child that E has? E has no child. So its degree is 0. So you can write for all other nodes like that. For C, what is the degree? 2. So number of child for particular node is its degree. So I can define like that. Now let us see what is internal node or non-leaf node or I can tell it as non-terminal node. So the nodes whose degree is not equal to 0 means that if it's greater than 0, then that nodes are called as non-leaf node. For example, B has 1 degree, right? It has 1 child. C is a internal node, or you can call it as a non-leaf node or non-terminal node. Let me call it as non-leaf. So all other names you can remember. So D is a non-leaf node. Okay, G is also a non-leaf node. F is what? F is not a non-leaf node because its child number of child it has is 0. Right? Means degree is 0. If degree is 0, that they are called as leaf nodes. Right? Again, leaf node, another definition. The node which has a degree 0 is called leaf node. Or what you can call? You can call terminal node. You can call external node. All these things you can call. So level. Now let us see level. Level means normal level. What I said. This is the first level, second level, third level. So what is height? How do you define height? Like how many edges are needed to come to this node, to this A? How many edges are required? 0, because it is only the parent. It has no parent at all. So number of edges to reach this node is what? 0. So I wrote 0. So number of edges that are required to reach B is what? 1. See, 1 node edge is enough to reach B. So 1. So what is the number of edges that are required to reach G? So you need minimum number of edge, or you can take it as normal edge. How many number of edges are required? 1, 2. So 2 edges are required. So again, height is nothing but the number of edges that are required to that particular node. That is called as height. So this is and again another topic is again forest. Means it is a collection of tree is called as forest. Imagine there are many trees like this, so that you can call it as a forest, right? So in next this is my first video on tree. Again I said, so you can follow the playlist. I will put all the videos in order so you can learn everything. So thank you. If you like this video, please subscribe, and if you understood this video, please like this video. Thank you.